Going back to the issue of how a globally characterized fungi in terms of what they do on the environment. Again, to repeat, they feed us, they heal us, and they harm us. So they feed us. Some of the examples of this microstructure that we see here that we can eat. There are other ways that fungi are feeding us, and that has to do with us utilizing them in industrial processing. For instance, in the food and beverage industry, fungi have been used in the processing of some of the aspects of the food production. And you all, if you have eaten cheese and you like cheese, we do know fungi can be utilized in the making of cheese. And in the making of bread, in the making of beer, or some of the alcohol beverages. So fungi are utilized in making those food or drinks that we cherish pretty much. In the same token, fungi also can harm us. So in this picture here, we're looking at some mycosis. So these are fungal diseases of skin that we will be talking about at some point during the semester. So not only they could cause problem in human and animal, but they could also cause problem in plant. So the biological factors is not always what we will term as benevolent. It's not always good in terms of the activities, in terms of the output. But by and large, they do have a role to play in our environment, not only in terms of delicacies for us, in terms of being utilized in processes in the food and beverage industry. They do play also a role in the environment in terms of recycling. They're able to degrade the complex substances and reducing those to a byproduct that we can utilize. Also at the same time, during the processes of the raw material, they also leave behind some byproduct, which can be divided, what I would term, in a good group, also bad group. For instance, you all recall the historical work of Sir Fleming, Alexander Fleming, which is one classical example given in microbiology in terms of how a researcher, by accidental finding, has come across a particular fungus, which we know he did some more work, and at the end was able to characterize the particular fungus and its byproduct that came to be known as penicillin. And penicillin has revolutionized medicine, as we know. And from that initial finding, many more development in the area of fungal metabolism have been made, and then we have taken advantage of the work in this area. Before ending up this basic introduction on the fungi, the one thing I would like you to remember is that I've gone through illustrating what is the building block of a fungi. Okay, that building block leading to the mycelium. But one very important component of a fungi cell wall is chitin. That sets them apart from some other organism that we will be talking about later. So if nothing else, as we leave today, just remember one of the main components in the cell wall of fungi is chitin. Okay? And the chitin in the cell wall, in addition to other compound or constituent, help the fungi cell wall or give a rigidity to the fungal hyphae. So as I said earlier, this tube here give you the notion of fluxes, but that's not the case. This is simply to give you the notion of a three-dimensional aspect of that tube. But because that tube can be surrounded by cell wall, which are rigid because of components like chitin and others, so it's rigid. So we're going to be studying that cell wall and seeing the differences between the different group within the true fungi. Now, chitin is also found in other organisms like crustaceous, crab, shrimp. So that led me to make this statement. All fungi, true fungi, do contain chitin, but not all organisms containing chitin are fungi. Okay? I want to leave you with that to reflect on. So all true fungi have chitin in the cell wall, but all organisms that have chitin are not necessarily fungi.